Welcome to day 2 of covalent compounds. Today we are going to be learning about naming and writing formulas for covalent compounds. So we've previously covered ionic compounds. Today we're going to learn the covalent rules. Luckily, these are a lot easier than the ionic rules. All right, a little bit of essential background information. Ionic bonds occur between a metal and a nonmetal, and in an ionic bond, electrons are transferred. Okay, so they go from the metal to the nonmetal. However, covalent bonds are different. These only occur between two or more nonmetals. So no metals are involved. And in a covalent bond, electrons are shared instead of transferred. All right, so when we are naming compounds, you have to be careful to decide which set of naming rules to use. So I have this little flowchart here, and if you go through the flowchart, you want to be thinking, first, is a metal present? If a metal is present, okay, for sure, then you know it is going to be the ionic bond rules. Then we go down from there. Does the metal form more than one cation? So if not, we're going to use the element name for the cation. So basically, this is a more complicated way of saying, does it have different oxidation states? Basically, this box means, is it a transition metal? So if it is a transition metal, then we're going to use those Roman numerals. If it is not a transition metal, if it's in the alkali metals or the alkaline earth metals, then we're going to just name it. If there isn't a metal present, then we're going to use prefixes, which we are going to learn about today. That means it's a covalent compound. So when we're naming a covalent molecule, first thing we want to do is write the name of the first element. If there is more than one atom, we're going to use a prefix, and we're going to talk about what that means in just a minute. The next thing we want to do is identify the number of atoms in the second element. We're going to do that by using the subscripts. Just like we learned when we were doing molar mass, our subscripts are going to be used to tell us the amount of atoms that are present. Then finally, just like we did before, we're going to change the name of the second element to the ending IDE. So just like before. Here are our prefixes for steps 1 and 2. So first one is mono. 2, we're going to use the prefix di. 3, we're going to use the prefix tri. 4 is tetra. Think about like the game Tetris, if any of you remember what that is. 5, we're going to use penta, like a pentagon. 6, hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Now notice this little asterisk here where it says we only use mono if the last element, never the first, has only one atom. My example is carbon monoxide. Okay, we don't say monocarbon monoxide, we say carbon monoxide. So if the first element has no subscripts, we're not going to use mono. Okay. We'll continue with that in a minute. And it's a little Moana joke previously. It says, you can't expect a demigod to beat a decapod. Look it up. It's from Moana. Okay, so here are some examples. It says, this first one says, silicon dioxide. Remember, there's an understood 1 right here, so we're not going to name it mono silicon dioxide. We don't use mono for the first one, so that's why that's silicon dioxide. So here we see a 4. So we're going to use the prefix tetra. Tetra. phosphorus. Okay, and then this says 10, so that's deca, but we don't use the A when we're using oxygen just because of how English vowels go together. So that would be decoxide, because in English A and O just don't really sound great together. Okay, our next one we're going to do, there's a 2, so it's dinitrogen. And again, just because of the A, penta and fluorine, we're going to drop the A. So we'll say pentafluoride. Oh, sorry, we are going to use the A because it's not oxygen. So that will be pentafluoride. Pentafluoride. Okay, pentafluoride. And then these are both having an understood 1 for their amounts. However, we do not use mono, just like in this first one, we don't use mono for the first one. So we're not going to say monosilicon, we're going to say silicon. But we will use it for the second one. Monosulfide. So this is much easier than the ionic naming. Remember how there were all those exceptions for ionic? There aren't really a lot of exceptions for these. Much simpler. Okay, so when we write formulas, again, we're going to use our prefixes to find out how many atoms are there, but we do not reduce these, and we also don't have to crisscross. These are much simpler. So we do not reduce, even if you can, and that's because we use what are called molecular formulas for covalent compounds and empirical formulas or simplified formulas for ionic compounds. So in a covalent compound, you want to count each and every single molecule. We never ever reduce. In ionic, you have to reduce, otherwise it is incorrect. So a little bit of a difference there. Okay, so let's do an example. So this says phosphorus difluoride. So the phosphorus, it's an understood 1. Okay, we don't need to write the 1. It's understood to be there. Difluoride. P-F, di, meaning 2. No crisscrossing involved in these. Remember, the whole reason you crisscrossed in an ionic bond is because they were transferring electrons. These ones are just sharing their electrons, so we don't need a crisscross. So this one says trinitrogen. Nitrogen. Tri is a 3. Pentasulfide. S5. Penta is 5. Okay, hexa, meaning 6, so H, 6. Decoxide. Deca, again, is 10, but we drop the A because they just don't go well together in English, so we'll say O with a 10. Now, this one we could potentially reduce, but again, because it's a covalent compound, we do not reduce. We do not reduce, so we are not going to simplify. Okay, so next there's going to be some instructions to make a foldable. So if you want to follow along at home and make a foldable, what we want to do is take some time to make a foldable. And it's going to look something like this. And you can make one at home. So on a piece of paper, first you're going to write an ionic and covalent. So if you took a piece of paper and just folded it in half, on one side, on the left side you can write ionic, and these transfer their electrons. So they're going to transfer. This is showing that they transfer. So it'll go from the metal, and I wrote, they have a metal, right? So you might want to say metal plus nonmetal. And I do encourage everyone to make one of these at home because it can help just kind of organize your thoughts. So on the left side, we've got our ionic compounds. That's a metal and a nonmetal, and they transfer. On the right side, you've got your covalent compounds. Okay, and these share their electrons. And I was showing that they share because you see the C for covalent, and they're sharing. That's what this arrow is. They're coming together. So it's like the circle is getting closed because they're sharing. But it's supposed to be like a C that has that circle coming together. They share their electrons. They don't transfer. And this is only nonmetals. Nonmetals only. Nonmetals only. Okay. So on the other side, on the inside, on the left, so again, if you made a foldable, if you open up the piece of paper, then you're going to write the description of first the ionic. So on the left side of your paper, this just gives you some of your naming rules in a summary. It says, okay, so our covalent compounds are metals plus nonmetals, and we do our formulas for the ionic compounds using our 4-step formula. Step 1 is our symbols. You can see that here, right? We're going to do our symbols. So if it was, for example, we were formula writing, and we were given a name, and it was aluminum oxide. Okay? So if it was aluminum oxide, I'm actually going to go back and make this a little neater for y'all. So given the name aluminum oxide, and we needed to turn it into a formula. So your step 1 would be to change it to a symbol. So there's the Al and there's the O. Step 2 is charges. So that is a +3 and a -2. Step 3 is crisscross. So the 3 goes over to the other side. The 2 goes over to the other side. And reduce and erase if needed. If needed. Not everything can be reduced. Okay, so for naming, okay, not formula writing, but for naming, the names may have Roman numerals in them. And you might want to write something about transition metals. Because those are the ones that get those Roman numerals, right? For example, I wrote iron 3 sulfide, so that would be iron 3, okay? So if you had a formula that was iron 3, this would look like this formula. Iron 3 sulfide, that would be a -2, crisscross. Okay, now we're going to look at the nonmetal side, our covalents. So I'll start with the top. These are only nonmetals. That's what you would want to write on your piece of paper. Because remember, you can use your foldable on your test, and it's handy to have all that information in one spot. For these, we translate our formulas. There is a prefix in the front, and we're going to change that to a number. So my example here is if you're given the name trifluorine dioxide, okay, with the tri, we know that means that there's 3 of them, and the di, that's the prefix for 2. Okay, there is no crisscrossing in these and no reducing. What you see is what you get. Okay, and here's the bottom of it. Oop. And I cannot grab it. There we go. So for these compounds, the names must have at least one prefix. So for example, sulfur monoxide, even in this example, we never, ever use mono for the first one. So if the first one doesn't have a subscript, we're not going to call it mono sulfur monoxide, just like for carbon monoxide. We don't put the mono for the first one, okay? But most of them will have two. So like the one up here, trifluorine dioxide. So the only exception is if there's only one in the front. And then I listed out the prefixes. And I very highly recommend making a foldable of your own just because it is very, very handy to have that. So I'll move it over one more time so you can make sure you've written everything down. Here's that metals. And there's the non-metal side. And we'll also post a copy of this foldable on Canvas. And that is it for today. So we're going to move on to our homework video. Make sure you make your foldable.